Welcome to the iBio Info Night. The agenda is up on, it's only 6:08, so we're going to be another 52 minutes. So in terms of the agenda, it's basically broken up into, we have some wonderful faculty representatives. I was so tempted to say it, Dr. Wool, but I won't do that. So that's going to happen until about 8 o'clock. At 8 o'clock, we're going to take a 15-minute intermission for those of you who are breaking your fast for Ramadan. And then we will have a student panel. And so we have both faculty and students here. So I'll pass it over to Vince Leung.
Oh, thanks, man. Okay. Oh, how does it work? Is it left, right? Okay. I'll figure it out. Okay. Good evening. Thanks for coming for this info night. My name is Dr. Vince Leung, and I'm from the Department of Chemical Engineering. I'm also the Associate Director for the iBioMed program. Most of you will see me next year in 2PO3. And yeah, once again, thanks for coming. I forgot how it looks like to have a full lecture hall. Anyways, so we're here to talk about the different streams. So here I'm representing chemical engineering. So the first question is, what is chemical engineering? So we could read this boring description. Chemical engineering deals with production and processing of materials and chemicals in a safe, sustainable, and profitable way. Pretty much what we do is we take raw material and we process it, we add value to it, and then we make it into some sort of more valuable product. Okay, it could be chemicals, it could be non-chemicals. Okay, it could be energy, it could be pharmaceutical, all that stuff. Okay, so we take raw material and then we process and then we make it into a good product that we can sell for more money. Okay, so what can you do with a chemical engineering degree? So we have all these people, come on in. Yeah, take your time, yeah. Cool, okay. All right, so all our students, I mean, every company that's represented here, we have one of our alumni or one of our co-op students that have been working there. Recently, a lot of students, especially in the iBioMed program, have worked for like pharmaceuticals companies. So let's just say Sanofi or AstraZeneca or this place called Septidon in Cambridge that likes to hire a lot of our graduates or even our co-op students. But also places like PepsiCo if you're into the food industry, or energy, so kind of like the Shell, or chemical, which is like Dow and 3M, and then water treatment like Suez. So like anything that you can think of, really, you could probably work at. We even have students that have worked for like Tesla. You might not think Tesla is a chemical engineering company, but they make stuff, they have production lines, things like that, and they'll hire some chemical engineering as well. And we have also students that have worked for banks and whatnot, so not just necessarily in the chemical industry. So our department at a glance, so we have a lot of good research. We are versatile, as you can see, with all the types of jobs that you can get. We have fantastic teaching, we have a great student community, and we offer a lot of research opportunities. We obviously offer to our students, but also if you're coming out of first year, you might be connected with some of our faculty members for research this summer already, because we do hire a lot. Okay, so research. The main areas of research in our department is bioengineering, as many of you would be interested probably from the iBioMed program, but there is also process system engineering. I think Frank, who's one of our student, representative, have that experience in the PSE stream. Water and energy technology, so if you're interested in green energy and whatnot, we have research in that as well. And then polymer materials and manufacturing. Okay, so just a few things that have been on the news recently for our department: green fuels, machine learning and AI, using AI for drug discovery in the Zhang's lab, vaccine manufacturing in the La Tulip lab and the Felipe's lab, tissue assembly, again, in the Zhang's lab, and then sustainable CO2 in the Higgins lab. So these are just a few of the topics that you might see. Again, if you're interested in research, feel free to talk to me, and I will connect you to a specific faculty. Yeah. Okay, so talk about teaching excellence. ChemEng is here in orange. I don't remember what year this is. We're just better than the rest of the departments. The end. Okay. Also, across Canada, we also have teaching excellence across Canada. So all the ChemEng departments across Canada, they meet once a year at a conference. And we were voted 5 out of 10 categories first. So again, we do have a good reputation in terms of teaching excellence. We also have a great ChemEng society. We have a great community of students, as well as just our relationship with the faculty and the students. We have fun things together, like, what do we call now? Not smokers, but like pump. So like where we go out and have drinks together, or we have industry night and all that stuff. So if you join ChemEng, you will be joining this wonderful, I guess, group of student community as well. ChemEng courses, these are the level 2, kind of boring. I would just want to highlight the main ones that you could do. So we do have streaming in ChemEng. You are already in the biomed stream. But let's just say you're interested in process system engineering. You could take big data, digital process control, and optimization. You still have that option. You have enough electives to select a stream as well. Okay, obviously not the bio stream because you're already in the bio stream, but you could also select the other 3 streams as well. Okay. And the last thing, thanks Zach. I see that. I purposely ignored you the first time, but it's okay. There is, so if you want to know more about ChemEng specifically, we do have a ChemEng info session March 20th at 6 p.m. In ITB AB 102. So just keep that date on your calendar if you're interested. Okay, I'm going to ask Dr. Weeb to come to talk about civil.
Thanks, Dr. Long. All right, hi everyone, my name is Liddell Weeb. I'm gonna grab this too. And I'm here from civil engineering, where our tagline is building healthier communities. What that looks like for us is generally different, I think, than a lot of what you've seen in first year, but I think something that could be really interesting and exciting for some of you. So when you think of civil engineering, there's a good chance that you think of buildings and bridges, and that's a part of civil engineering. That's structural engineering, which is my area of expertise, but it's not all that we do in civil engineering. And I think that the thread that holds everything together in civil engineering is that we're really at the core of civilization. Anything that's really foundational to making a civilization work is generally a civil engineering sort of thing. So yes, buildings and bridges. Also things like clean drinking water is kind of at the intersection between civil and chemical engineering. Transportation systems, any of this like infrastructure that's really foundational to human health and well-being is a civil engineering sort of thing. The categories that we talk about it in our department are resilient infrastructure systems, water security, smarter mobility, and intelligent energy systems. I'm going to focus more on the first 3 of those and start actually with water security. So when we talk about water security, what we mean is having a reliable access to an appropriate quantity and quality of water. And these are things that are threatened right now. With global climate change, we have both more frequent droughts than have historically been the case, and also more frequent flooding and rainfall events. And in both cases, how to manage all of that water is a civil engineering problem. Water treatment as well. So how do we ensure that when you turn the tap, you have clean drinking water, that when you flush the toilet, it doesn't just go out and make everyone sick? Those are civil engineering activities as well. And the provision of clean drinking water is arguably, at least, the most important public health development ever. And it's really one of the key things that we do in civil engineering. So some of the opportunities to learn about these sorts of things throughout the program, there's lots of courses related to different aspects of water, both on the water treatment side and the stormwater side of things. And then in the 4th year level, there's some opportunity to specialize in things that might interest you related to water. On the mobility side of things, so transportation engineering, how do we move large numbers of people around? So both public transit, how do you get people out of cars and get them more active in their lives? These are civil engineering sorts of questions. There's lots of layers to that kind of active transit question, but a piece of it is around what we do as civil engineers. near and dear to my heart is the resilient infrastructure systems. This is an image from the World Health Organization of the recovery after the Turkey earthquakes last year. My particular area of expertise is in designing structures to be safe for earthquakes. And that's really foundational, obviously. You're not very healthy if you're not alive. And it's often said earthquakes don't kill people, buildings do. So if you want to know how to design a building that's not going to kill people, you should come take my classes. So those are the sorts of things that we do. Again, it's very different from what you're seeing in 1P10, where you tend to design like a device that's going to help an individual. We deal with things that are big, that are one of a kind, that are iconic a lot of the time, that are foundational. And yeah, so it's just a different way of engaging with human health, but I think something that may be of interest to you. So if you're curious to learn more about it, and you're not totally pizzaed out from tonight, we will have more pizza at our info session tomorrow night at 5:30 in JHE A101. Hope to see some of you there. I think that's it for me. And who's next? Howdy.
All right. So hey everyone. So I'm Mike Noseworthy. I'm a professor in electrical and computer engineering, and a bit of an odd one. I'm also the associate chair of radiology or Department of Medical Imaging too. So got one foot in healthcare. Well, one big foot in engineering, one littler foot in healthcare. So anyway, so I'm going to talk about, I guess they didn't like the pizza. So some application areas in terms of electrical and biomedical engineering. There's quite a few, but just a few highlights. Medical imaging is one. I think you can maybe guess right away that that's my favorite. And I just want to say that we are pretty happy here in terms of you guys will see in fourth year, we have a nice medical imaging course that we have some small MRI systems and CT systems to play with. And if you do electrical engineering, we have a human MRI and human CT scanners that are just in the IAHS building or the MOMAC building or the Mohawk building or the nursing building. I mean, I've heard all these different synonyms, but just right over there where you get pizza, there's a nice 3 Tesla MRI sitting in the basement there that I'm always sitting there working with. There's other applications like wearable sensors, wearable tech, sensors in hospitals, you name it. I will say if you like big data, medical data is probably the biggest source of data you'll ever run into, especially medical imaging. We've got, exabytes of data. I mean, there's so much data one can tap into for if you're interested in AI. Other sorts of things, surgical robotics. Come on in. You for the iBioMed Info Night? Oh, good. Yeah. Okay, good. You answered the right question then. Okay, come on in. So some of the other applications, things like surgical robotics is a big application. If you're interested in that, we have an excellent medical robotics group at St. Joseph's Healthcare here in Hamilton. And this is an old friend of mine, Anthony Adili. Anthony actually did the electrical engineering and management program here at McMaster before he did medicine. And now he's an orthopedic surgeon, was the head of surgery for a while. And he actually performed the very first robotically assisted knee transplant in Canada. And that's him in action right there. And we definitely have a lot of surgical robots over at St. Joe's. So it's a definite area of interest if that's something that you find really fascinating. I myself do a lot of work with patients. So working in engineering and healthcare is a really nice mix. You get direct interactions with patients, which I find really quite satisfying. Other applications include biomedical signal processing and control. So example, things like brain-computer interfaces is a big thing. And I know I did projects with various students over the years, developing wheelchairs that are controllable with your brain. We actually did that for capstone projects many times, which was quite fun to be able to steer a wheelchair around based just on thinking about which direction you want to go. So we do that kind of stuff in electrical. And if you like signal processing and image processing, this is the area to be for sure. A lot of key courses we have, obviously biomedical signals and systems, which I believe you all take. Medical imaging 1, that's a great course right there. Definitely take it. It's a really good course, I've heard. And other courses, bioelectricity, modeling of biological systems. And I thought that used to be 4QZ4 or something, or 4QZ3, whatever it's called. And then, of course, there's advanced imaging through electrical engineering, which is 4BF4 ElecEng, which is, again, with the real advanced stuff. Don't even make pictures for the first month because it's just math. If you like that, then it's a great course. So, and also there's a lot of machine learning and AI stuff within our department in terms of analyzing, you name it, with regard to sensors and technology. So we definitely have a lot of data. And if that's your thing, 1 minute already? Okay, wow, okay. So there's been a lot of student successes over the years with the electrical and biomed students. There was a team that actually made this CPR glove that they sold. It was patented and the whole bit, and the students from that actually made a good pile of money. That's one good success story. And this group right here, this is a fellow named Mr. Dyson. So he actually, the Dyson vacuum cleaner guy, you know, he has an award every year for engineering projects and a global award. And this team right here were Elec and biomed students. I actually did the engineering supervision of them, and my colleague Raymond Wong, who's a radiation oncologist, gave them the clinical information, and they actually won the Dyson Award, which was brilliant for a little detector that detected and scored melanoma in skin, which was really brilliant. So, and that we were really proud of those guys to actually do that. So, yeah, there's me. If you have any questions, that's my mugshot. Yeah. I know. I just noticed that when it's on the big screen. Yeah. Anyway, I'm gonna thanks. Yeah, imaging.
Okay, my name is Nico Hildebrands. I am a professor in engineering physics, obviously. I still have to look there because I've been here only since September, so I don't know much about my own department or the other departments, but I'm working in biosensors. So we're developing biosensors with nanoparticles. So you can see here a lot of nanoparticles that you can put in food or in immunoassays on zebrafish to make biosensors. And that's a part of engineering physics. I skipped the part what engineering physics is because engineering physics is a lot of things. And if I also don't know why professors have to talk here. If I was a student, I would ask a student from last year what to choose and how it is and not believe in any professor. Yeah, now I have to say believe in me. So this is the numbers, I think, of, I was given this, this table. What you can do in engineering physics, and we blinded out all the others, not HESE, I don't know why, is that we can have a lot of elects. So you can basically make whatever you want if you're in engineering physics, choose different things that you want to go into if you want to make nuclear physics for medicine, or if you're only in iBioMed to hide that you actually want to build a nuclear bomb, you can do that also in our department, obviously. So things that you can specialize in is very broad. I talked a bit about nanotech, so it's nanotechnical engineering, nano micro devices. We have a lot of photonics and optics if you're interested in solar devices, or nuclear engineering. That's things that you can do in our department. Another thing is the cross-disciplinarity. So if you want to go into space systems engineering, so all can be chosen as an elect, I guess. Quantum computing, AI and machine learning, or even pre-med, these are things that you can do in engineering physics. So build the, I don't even know what that is, but it looks fancy, build the next generation of modern cities. Or you can go into biomedical EngPhys. So this is high-tech research specialties. So you can see it here. These are small nanorobots that you can use, something for vision development. Here are, again, some nanoparticles, I guess. So these would be biosensors. I am teaching in biosensors, for example. There's biophotonics. So if you want to use photonics for detecting biomolecules, all nuclear medicine and radiation physics. So there's the only nuclear reactor in Canada here that you can use for such things. So it's actually not really very dangerous, I suppose. More reasons to study or to take engineering physics is we have small class sizes and great supportive community. You'll focus on understanding why things actually work and learn how they work, which is kind of important so you can choose what you want to do afterwards. For sure, like everybody else, we're teaching only cool things. You'll find out yourself, but I don't know. I suppose that's somehow important. And we're making the bridges vibrate. So civil engineering builds them, and we march over them. But now you can do it better, I guess. I think that's it already. It is. Thank you for your attention.
All right, let's talk about HESE, the Health Engineering Science and Entrepreneurship stream. So HESE is a 4-year program that leads to an honors bachelor of health sciences in health, engineering science, and entrepreneurship. So in this program, you get to design, create, and build and bring health innovations to market and into the hands of those that need it. And what's unique about HESE is that you apply those foundational biomedical engineering and health concepts from iBioMed with an additional business aspect as well. So students in HESE, you get to develop a skill set across 3 disciplines. You've got health sciences, engineering, and entrepreneurship. So we'll look a little bit closer into each one of these. So in health sciences, these courses mainly focus on human biology and anatomy and applying that to biomedical innovation and research. And these are just a few of the courses that you will take. In terms of the engineering side, these courses focus on the design and application to the biomedical field. And it's important to note that in HESE, you're taking fewer engineering courses compared to the BME streams. So for example, in year 4, you would only take 3 of these 6 options. And that third pillar of entrepreneurship, these courses focus on designing for your end user and creating a market-ready innovation. And some of the topics are listed here. And one of the courses that ties all of this together is Innovators in Scrubs. So Innovators in Scrubs is a upper year HESE course where students go into clinical placements at Hamilton hospitals, and you get to explore and experience a variety of clinical areas. So some of these are neurosurgery, vascular surgery, interventional radiology, and so many more, and there's even more that aren't listed here. So it's a very unique course, and in this course, you get to explore those different areas. So you're not assigned to just one clinical area, you get to get exposure to multiple clinical areas, and you get to work with healthcare professionals like surgeons, other healthcare staff like nurses, as well as patients, to really understand the clinical needs and unmet needs that exist in the healthcare field. So you're going in with a fresh set of eyes and trying to find areas that there are issues, and then coming back to the classroom to create a biomedical innovation to help fulfill some of these real challenges faced by your preceptors. So then when you are back in the classroom or back at McMaster, you can design and test out your prototypes working with clinical staff, or you can even test them out at hospitals with your surgeons. So in this picture, we have neurosurgeon Dr. Bill Wong working with some Innovators in Scrubs students, testing out their innovation of an endotracheal tube. And they're at a simulation lab here, so they get to work with simulated patients. And you get to work with them to also create different iterations of your prototype and really tailor your innovation to their needs. So this is the rest of that team that created the manipulette, or that endotracheal tube we just talked about. And they've been doing such amazing things, and they've won awards for their innovation, and they're also patenting their device now, so very exciting. You may also recognize Liana Genovesi. Even though she's a BME grad, she does encompass and embody everything that HESE is, and she's expressed how HESE's entrepreneurship side could have also helped her with starting up her own company. So she has founded Imaginable Solutions, and she receives mentorship and education from HESE faculty and works with the clinic at Mac. So this is a health innovation incubator at McMaster that HESE students also have access to. So who knows, you might be the next student to spin out your own company through HESE's entrepreneurship lens. In HESE, you also have the opportunity to explore research through your thesis. So you get the chance to work with a supervisor in a lab, and this can open up opportunities for graduate school or exploring research skills further, or even getting some publications. And HESE students have been publishing in primary journal articles, and these are just a few of the journals that they've published in, and the list is much longer than this too, but it's really it's such a great feat to accomplish in undergrad to have a published paper. So in HESE, you also get elective space to really craft your own future and build your own degree. So you can take courses that you have a side interest in, or that can be used to pursue a minor, or even if you wanted to take some courses to boost your GPA to get into medical school, for example, you have that space through your electives in HESE. So you have so many options here that can open up opportunities for grad school as well. So these are what some HESE students are up to right now, going to grad school, doing their masters or even PhDs like MD PhDs. They're in professional school doing medicine and dentistry, and even in industry working at companies that are related to engineering or even business. So there's so many options that you have with your diverse skill set in engineering, entrepreneurship, and health sciences. And if you like what you heard, come innovate with us in HESE, and HESE for yourself how you can go from idea to innovation to impact. And we also have social medias if you're interested in following us and just keeping tabs on what we're doing. We have one for innovators and scrubs, as well as the general McMaster iBioMed. And if you want to learn more, join us at the HESE Info Night on March 21st at PGCLL M21 at 5:30. So we hope to see you there, and thank you, everyone.
Hey. Ooh, I gotta watch the time. Okay. Nice to see all of you. I know you know who I am already, if you've been in lecture, that is. Most of you have, so it's all good. And I'm going to tell you in 5 minutes, if I can, without getting kicked off the stage like Dr. Leung did, about materials in about 5 minutes. Okay, here I go. So, and we've already had our info session. I know I saw a few people out, but you'll get a quick summary of it here. And if you have more questions, we're going to have a booth. You might have seen this before, but in PGCLL. So we'll be there all day, so you can come by before or after 1P10 if you have other questions. There'll be some students, graduate students, faculty throughout the day at the booth that we have set up on Monday, March 25th. And then there'll be some students here, and feel free to ask questions if you have others. So I know you know a bit about materials from our 1P10 lectures, but I'll give you a summary again about what materials engineers do. So we're always creating new materials, and these can have exciting different properties in a whole range of areas, sometimes developing new processes as well, and overall just engineering solutions to these grand challenges that we have. So in health, a big one that most of you are probably interested in, as well as energy, manufacturing, and other areas. So we know materials are everywhere and everything, so you can think of all sorts of different products. Some of the key ones here that you might be interested in that really do help to change the world for the better. So healthcare, clean energy, manufacturing, sustainability, biomedical materials, and there's a lot of overlap with these within materials, biomaterials as well, so that you could apply, or you might find you want to actually take materials and do things other than work in biomedical applications. So our department has been ranked in the top 50 in the world and first in Canada over time. And we have a whole list of companies that students have gone and done co-op in. We're just listing a few here of some of our graduates and some of the co-ops they've had. But in our other sessions, we have a whole list of the companies. And actually, you might have come by the industry night that students put on and seen all the different companies that have taken materials graduates. So here's one example. So Amanda Clifford actually started out as an undergrad engineering student in materials. She then stayed and did a PhD with Dr. Igor Zitomirsky working on modifications of materials for sensing applications. Oh, it's not a student, it's catering. Okay, sorry. More food. Oh no, it's cutting into my time. I gotta keep going. Okay. Dr. Clifford is now a professor at UBC. So she had some time doing research even throughout her undergrad and at the company Tech. Ariana Hurley, she recently graduated from the iBioMed program. She had a few different co-ops as well in the Granfield Research Group, at Octane Biomedical in Kingston, applying her materials skills there. She also, I think both of these students actually did a placement at time and in Grenoble in France, so I'll tell you a little bit more about that quickly. Adam Tidmeers, he also had a lot of different co-ops, worked at Apple doing materials development and testing, and now he works for a startup company in Dundas doing a lot of exciting applications of materials. So we have various areas that students can specialize, as well as research that's going on in the department. So of course, biomaterials, you hear quite a bit from me. We have other faculty members working in biomaterials, and as well in materials for manufacturing and infrastructure, smart materials and devices, and data analytics and computational materials. And there's also a lot of ways that these can overlap. So for example, for biomedical applications, making smart materials and devices, additive manufacturing, as you know, lots of ways of 3D printing for biomaterials, and then combining computational aspects for accelerated materials discovery. Some options for courses, you can see in second year, students learn about bonding, crystallography, mixing of materials and equilibrium, and a lot of the fundamentals that then build upon in upper years. Overall, in your upper years, you have a chance to take a lot of different electives as well, so 6 to 9 electives. So just a little bit more about the courses specifically in biomaterials. So 2AO4 is a course that allows students right away to get hands-on experience doing some labs in biomedical case studies, so polymers, softer materials, ceramics, and metals. 3BO3, you get to learn more about manufacturing, sensors as well, there's a lot of applications. Dr. Brian Lee teaches biomaterials and tissue engineering. I have taught and will continue to teach for LB2 a new hands-on biomaterials lab course. So it's a small course right now, and it really gives students a chance to get hands-on experience. And then I also teach materials for YO3, advanced biomaterials, where we have lots of guest lectures from industry, government, academics, and myself teaching a lot about the different areas that you can apply biomaterials. You can work on biopolymers, corrosion of materials, synthesis of nanomaterials, characterization, and so on. A new thing this year is our computer science minor that's possible, and as well there'll be a nuclear engineering minor coming soon. Lots of opportunities for interns and fellowships. Our students get a lot of paid research jobs, and we help with that. We have MSc only study spaces because we're a smaller department, spaces where only our students can go and work and collaborate and network, small class sizes, great statistics in terms of enrollment. And again, this Grenoble exchange. And we also have partnerships with the University of Tokyo. So we've had students go to Japan, lots of students that go to France and do some of their coursework in France. Some of them do research as well. And then you might get a chance to do tours, if not already, of our Canadian Center for Electron Microscopy, which a lot of our faculty members do research in, and a lot of our courses even allow you to get hands-on experience using these tools, which are really great for getting jobs. McMaster Innovation Park, we have some researchers there, the Biointerfaces Institute, and the McMaster Steel Research Center. Finally, we have a great student community, and I'm getting the warning, but I could talk, this is good, I can talk about the students, and I'll let, even more importantly, the students talk about what they get involved in, the courses they like. So the Materials Society, they put on the amazing industry night that already happened, and that happens every year. They get to network with the industry that are coming for that and give the opportunities to all the students. There's also Macsmiths, Delta Hacks, Baja, Mars Rover, Solar Car, a computational materials society, and lots of ways for students to get involved and interact with each other. So we're like a materials family, and please talk to the students when you get a chance to hear about their own experiences in the program. Thanks very much, and on to Dr. Wall. And the booth up there.
All right, hey everyone. I'm Greg Wall, and I'm in mechanical engineering. I saw some of you during your 1P10 design studios. So mechanical engineering. How does mechanical engineering relate to biomedical engineering? So we'll go through a couple of sequence of things here. I did things a little bit differently, actually. Liz Hassan, my colleague, did things a little differently, and I'm presenting for her. So who's that? It's Serena, right? Okay, so let's take a look at what Serena does and how mechanical engineering applies to what Serena is doing. And I'm going to start from the bottom right over here for you guys. The footwear, so whether it be the sport footwear that she uses, athletes use, or if we're talking about clinical scenarios, orthotics, and how people move. So adjusting and helping with gait. Looking at quantifying maximal muscle strength for function in mobility, or tissue properties generally, actually. Something that comes when we go to surgery, surgical robotics, remote surgery, something that's really important when we come in contact with the tissue, how that behaves with the instrument when it's coming in contact, or when we're looking at injuries and designing implants. Weaving machines to make these advanced textiles. So whether it's a certain property that we want from the material to control how the body moves a little bit, provide some sort of protection, but still some breathability. Mechanical engineering is involved in that, designing that and fabricating that racket or some of the other sport-related things, helmets, I'll get to that in just a minute. The projectile motion, whether that be this tennis ball, or a rocket, or what have you. Interpreting the sensors from these smartwatches, the physiologic sensors that are involved, and what that means for her physiologic motion and what she's doing. Motion capture, the kinematics, so how she moves, and if she moves differently, or maybe she's not doing things optimally, how can she adapt her motion, especially at the high performance level? So being involved in that sort of motion capture, and goodness, if things don't go so well for Serena, design of surgical sutures and staples. So I hope she doesn't end up here, but mechanical engineering is involved in this, and you've heard some about the robotics, and actually going to hear some more about the robotics in just a bit, I'm sure. Everyone thinks, when they think mechanical engineering and biomedical, they think design and testing of implants, and certainly we're involved in a lot of that. The tools that are involved in the surgical applications. Some of the things that I think some of the students are a little surprised about when they get into the second part of second year is the stuff related to thermodynamics, fluid flow, and heat transfer. It's involved with some of this stuff, the pumps, the gases, the anesthesia equipment, heating and ventilation systems in the OR. You always want a positive pressure in an OR, because when you open the doors, you don't want the bad air coming in. You want the good air going out and pushing the bad air away. If Serena does get injured and she needs to go through surgery, we might want to take a look at the biomechanics just before the assessment. So we might do that with some of the kinematic assessment. And then after she's gone through surgery, I shouldn't be saying that. That's a bad omen for her, right? If somebody happens to have to go through surgery, okay? So the assessing the post-op biomechanics, and then recovery, designing of assistive devices for use during recovery, okay? And helping with the physiotherapy and that sort of stuff. Speaking of injury, this sort of stuff, so you all get to be in these vehicles pretty much at least once a day, I'm sure, whether it be your bus or driving. So the design of test apparatus and instrumentation, these test dummies, most of the data we have right now, most of the data we have are from 50th percentile male crash test dummies, but more research has demonstrated that we need a female crash test dummy or small crash test dummies for children. And then the design of vehicle restraints associated with the different types, the seating ergonomics, vehicle standards, manufacturing. And then, again, what if things go wrong, forensic analysis of motor vehicle collisions, and injury biomechanics. So one of the advantages of mechanical engineering is the versatility of the discipline. If we were doctors, we'd be the general practitioners. So there's a lot of interdisciplinary play among all of the people that you're hearing from tonight. But we work a lot in the multidisciplinary teams in research and in development. And if something moves, generally it's related to mechanical engineering, unless it's that vibrating building that Dr. Wiebe was talking about. Still mechanical engineering, some, but mostly civil. So why might you go into mechanical engineering? Well, if you enjoy design and CAD, it's not just about CAD, though. So making things, there's a lot in that heat transfer and thermodynamic stuff as well. if you liked physics, and even if you didn't like physics, it's mostly about the applications of physics 1D. I went into physics, or no, I went into mechanical engineering because I kind of like thinking about like the 3D, I don't know, like orientation of things. Like I can tell you, Dr. McDonald earlier was pointing, I was like, oh yeah, my office. It's like, no, his office is over there. And I know because of my 3D awareness. And like, so I thought, okay, so that's like why I went into mechanical engineering. But you decide where you have to go. Oh no. So if you have more questions, you can message me. Our info night, the information is going to be coming up shortly. Thank you, and all right. Okay. Dr. Oniza. Oh, you want that? Sorry.
But I'm going to talk to you about two programs, software and mechatronics. So why go into either? Well, we have a lot of different areas of research, but first I'll talk to you about the three programs that are really run out of CES, which is computer science. So we have a degree program in computer science, but you have to be admitted directly into computer science. And then the ones that you're considering are mechatronics and software engineering. And then we also run a master's program in e-health combined with health sciences in the business school. So what does CES really cover? Our faculty are really active in mobile health system, medical information systems, medical devices, medical imaging and AI, medical robotics, which is actually my area of research, health and aging, safety and security of software-intensive systems. So our info night already happened. It was last week on March 6th. But if you have any questions and weren't able to make it, feel free to email casug@mcmaster.ca for any information. So mechatronics, why might you be interested in mechatronics? Well, maybe you're just really undecisive and you haven't decided between mechanical, electrical, and software. Mechatronics is the perfect program for you. I'm a mechatronics engineer, really is at the interface of working in a lot of those different areas. Maybe you're just really good at everything, and that's another great reason to choose mechatronics. Software engineering. So really, software engineering will not only just focus on writing code, which is a common misconception that people have. We do a lot of object-oriented design, a lot of requirements design and verification, and really assurance. A lot of software is found in literally every device that you deal with. So that's why assurance is such an important part. And then, of course, safety and security and how you actually build safe, secure, and reliable software. OK, so a few examples of why CES is actually so well placed to train students. Essentially, software is a universal thing that you come across, right? It's the universal ingredient in every device, everything that you're dealing with. No one, or very rarely, are we building physical calculators now. Now you just go online and you just program in whatever you're looking for, right? So that's why software is really the main ingredient in everything. Mechatronic systems is really thinking about deriving how medical device innovation through integration, right? That's really what we're dealing with. And then I'm just going to walk you through a couple of research projects, capstone projects that we have in our department. So we have projects related to eye surgery, imaging of the eye. So we have projects where you're actually detecting how you can design AI tools by taking images of the eye and detect specific eye conditions. I have a project where I'm building medical devices for eye surgery or to reduce the number of surgeries that people go through. You can also build focused ultrasound to, for example, have precision targeted delivery to minimize cancer. Here's mobile health solutions that we're building. So just a couple of the areas. Rong here is working in the area of healthy aging. This is actually research from one of my colleagues, Dr. Muradi, and he does a lot of work in medical imaging. So if you have a chance to hear one of his talks, he really does AI training of some of those medical images or how we can actually detect normal versus abnormal images. So he really works with big data and building a lot of AI systems. He has a lot of experience at IBM and Google building some of those tools. And then finally, Here's a slide on my research, which is focused on some of the small-scale medical robotics and specifically surgical robotics applications that I do. So here we built a 3D printer for fabrication of magnetic microrobots. Here's some applications of us working in the area of pediatric neurosurgery. So we were building small-scale graspers, scissors. Here's just me playing around with a Sony PlayStation controller to control this pair of scissors. All of this is magnetically actuated inside of a small coil system. Here's a lung phantom that we've built based off of a CT scan that we had, and we're able to navigate our robots down those lungs, down a pancreatic duct. And then finally, we have awesome students, right? So here's just examples of the Software Engineering Society and the Mechatronics Society. Here's some examples of events that they've recently held. So one of them was Profs, Papers, and Pizza. It was a great night where a bunch of profs and students got together, and we just discussed how to get involved in research, and we had a lot of pizza that we gorged on. And then another example is sushi night. And that's all I have for today.
Hi, everybody. If you don't know me, my name is Zach Edwards. I am the Communications and Engagement Coordinator for the program. I am here to sort of facilitate a panel discussion with some of our upper year students who have generously donated their time to talk to y'all about their stream and why their stream is the best. So why don't we go, and I'll just go down here, and you can tell me your name and your stream and why your stream is better than the other streams.
Okay, hi, my name is Cassandra, or Cassie, you can call me Cassie. I'm in my 3rd year of materials in iBio, and I really like materials. I'm not gonna say why it's better, but I am the Materials Society president currently, and I'm doing research this summer in computational materials, so you can talk to me about that, or biomedical materials.
Hi, I'm Sharanya. I'm in my 4th year of biomedical and mechanical engineering, and I chose this stream because I really like to CAD, and I wanted to design things for biomedical applications.
Hi, everyone. I'm Aiden. I am in my final year of mechanical and biomedical as well. And the reason I chose mechanical is because I'm fascinated by prosthetics and biomechanics and everything to do with that field. And this was the best way to combine both biomedical and mechanical into one program, hence what we're all doing here.
Hi, my name is Poonam. I'm in my 4th year of the HESE stream, and I chose HESE because I like engineering concepts, but not love it. So I thought I'll just take a baby bit of engineering and focus more on the health.
Hi, I'm Lauren. I'm in my 4th year of engineering physics and iBio, and I chose EngPhys because I'm a very indecisive person, and I just really loved physics. So you get to learn literally a little bit of everything and smush it all into one.
Hi, my name is Audrey. I'm in my 4th year of electrical and biomedical engineering at Mac. I'd say I chose electrical because it is a very well-established program in iBioMed. It's been around for a long time, and there's a lot of interesting applications with electrical engineering. No matter what you're into, you'll probably find something you like. And if you like computer engineering, you do a lot of that as well.
Hi, I'm Frank, 4th year Chem and iBio. I chose the Chem stream because I like my options. I like to keep my options open. We also have a very, very good faculty, as Dr. Lung said. And the coursework that we do is very similar and very, very broad. So you get to choose what you want to do after that. And yeah, a lot of options and good faculty. You can't really ask for anything more than that.
Hi, my name is Sina. I'm in my 4th year of software and biomedical engineering. I chose software because it really allows you to tap into any industry you want, because as it was said, it's really applicable to any industry you want to go into, because well, pretty much everything uses software nowadays, and it's obviously a growing field as well, so it allows for a lot of opportunities after you graduate.
Hi everyone, my name is Kylan. I'm in my 4th year of Tron iBio, and I chose Tron because I really wanted to look at the intersection between software, elec, and mech, and also, as Lauren was saying, I feel like if you don't know what you want to do and you're interested in all of them, it's a good way to hedge your bets as well.
I have a question for Cassie. What's the coolest part of materials engineering, and like the coolest biomedical part of materials?
sorry, but on the recording. How fracture is going to propagate throughout different mechanical properties, chemical forces is very cool to me. There's also a lot of different applications in tissue engineering and additive manufacturing and a lot of stuff that Dr. Saski is doing with hemoglobin and everything like that. It's very cool, very broad applications, a lot of different things, computational, smart, electronics that you can find in there.
All right, so my question's for Audrey. What are the actual like courses that you take in ELEC, and what was your favorite part about it?
Okay, so in electrical engineering at McMaster, you take the same classes that someone in computer engineering would take as well. So in your second year, it's going to be a mixture of like your general electronics course, which is a very good course, and it covers all the basic fundamentals of electrical engineering. And then you're going to take 2SI, which is like your basic principles of computer programming. So a lot of fundamentals in your beginning second year. So circuits, electromagnetics, and computer programming are your main things. And then as you get into the upper years, then you would specify in more specific things such as like logic design is a computer engineering course, where you focus on like digital logic, microprocessors is another course that you take. And then there's some more specific things. If you're interested in power, you can take like energy conversion or power systems, and basically a lot of different applications depending on what you're interested in. I think the second part of that question was like, what's your favorite part? That is a very wide question, but I would say I like the design aspects that you get to do in iBioMed with electronic principles. So for example, in our third year design class, we do a sensors project, and it's very cool getting to see the like specific applications of stuff you learn in your electrical courses being used on a biomedical project. So for example, we built a wearable device to measure gait in a cerebral palsy patient post-surgery. And it's just very nice to see like the things that you're doing in your other classes actually relate to biomedical streams and like the projects that you can do with them.
Would you say that it's like close to 1E03 physics? Do I have to love it?
Definitely not. I would hope that you don't hate it. That was a part of why I chose electrical, to be honest, is that I did enjoy 1E03. But if you don't hate it, that's fine. If you don't love it, it's okay, because there's a lot of different parts of electrical engineering as well. If you're really into like coding, like that would be another good thing to be into, or like just, yeah, you kind of need to like 1E03.
I have a question for Frank. What type of courses do you take in chemical, and are they related to pharmaceuticals or not really?
That's actually a really good question. So, I would say that a lot of the courses that we take aren't like directly related to pharmaceuticals, but they do have their applications in it. So Dr. Zhang teaches applications in biomedical or biomedical engineering. Like I think it's like 4T. So in your upper years, you'll take some courses that relate to pharmaceuticals. In your undergrad and second and third year, you're pretty much just learning like a very, very solid foundation of like how to be an engineer and like how to get these like chemical engineering principles down. Like Dr. Wohl was saying, we take like thermodynamics in chemistry as well. So you can't really hide from thermo or fluid mechanics if you take those streams. You're not hiding from it. But that being said, that doesn't mean there's no job prospects in the pharmaceutical department. I know a lot of my friends after their third and fourth year, even without like the absence of like taking these pharma courses, they still get jobs at these pharma locations and stuff like that. The three that are really popular now, I know Vince mentioned them, but Sanofi hires like a lot of Mac students. So does Septidon and AstraZeneca. Septidon actually has like a lot of positions for like the pharmaceutical industry. Just like a question for you, like what are you interested in the pharma like area? That's very, very cool. Yeah, so those companies will have like opportunities for that stuff. So yeah, if you are thinking that's the right way, I think chem's kind of your direction you should be going in. Yeah.
Okay, my question's also for Frank. What kind of co-ops or internships have you gotten to do throughout your time in chemical engineering?
Yeah, that's a great question. I do like talking about myself. So I've had 2 co-ops, and I'm starting one in May. As Dr. Lung was talking about, I'm just gonna call him Vince. That feels really weird to say, Dr. Lung. You'll know next year. But essentially, like, he was not lying about the research opportunities. There's a few big research groups within the chemical engineering department. One of them is the MACC, McMaster Advanced Controls Consortium. That's who I worked for after second year. And prior, like, opposite to like contrary belief, a lot of the positions at the MACC and some other like research positions in the chemical engineering department, you don't have to have NSERC, like the applications, to actually get paid. We do have a lot of grants that fund student research. So after second year, I worked with a professor called Dr. Schwartz in process system engineering, and I actually used neural networks to like approximate like large thermodynamic equations that were like 4th and 5th order. So that was my second year one, very cool. It was research at the school as well. And then in third year, I took another co-op at the school as well, doing research under Jake Neese. You probably haven't heard of him yet, you will. And that was for course development for one of the courses in chemical engineering called ChemEng 404. So in like the course development, I learned like how to develop a course from the inside out, how to like deal with these big physical chemical systems. Unfortunately, I haven't done a lot of biomedical engineering co-ops, so I can't really help you with that. But that being said, my last co-op is in industry, and as of May, I'm starting at DeFasco for a process engineer. And that's just like one of the many pathways students end up taking in the chemical engineering department. There is a biomedical engineering group, like I was just saying. Septidon, AstraZeneca, and Sanofi do hire a lot, so that's like really important. Like I know 2 or 3 of my friends have worked in pharma places as well. Yeah.
So I just have a question for Lauren. I saw in the presentation where I forgot his name, but he said about like learning the way of learning. Like, what are your experiences in terms of that, like in EngPhys department?
Yeah, so I would say that EngPhys is like I would say in a lot of other streams, you sort of learn applications. And so I'm just gonna pull to Audrey and talk about like elect versus EngPhys for a second. So like, this isn't a bad thing, but for example, in like elect, they do a lot of like transistor stuff, and they learn like how to incorporate transistors into like circuits and circuit design, which EngPhys sort of does too, but it more so focuses on like the bare bones of how a transistor works and like what's happening with like your electrons within like a semiconductor or like a PN diode or something like that. So it's a lot more, you sort of like what I was saying, how it's not necessarily about applying things, but learning how things work in its like fundamental sense. So I think that's the biggest thing that they talk about in EngPhys when they're talking about like you have to figure out how to learn. It's like learning how things actually work fundamentally rather than just taking them and running. Alec is also a great stream, guys. I'm not saying anything. It's personal preference.
I promise we also learn how things work.
They do. They definitely do.
This is more of a general question, whoever wants to answer it. But as someone who's really indecisive, and I had like thought I crossed things off, and now coming here, I've uncrossed things. What was your process to like coming to a decision on what to rank as your top stream?
I can sort of start just because I have it, and then if anyone else has anything to add, just pass them. Okay. For me, like the first thing that I sort of did was, I don't know if you've looked at this yet, but I looked at the academic calendar. Have you looked at that yet? No? Okay. So if you go online, you can look at the academic calendar for all 5 years if you choose the engineering stream of classes that you would take. Because I thought I was interested in some streams, and then I looked at them and I realized that those were things that I might not be as interested in, and like sort of the emphasis on certain courses and certain topics over others. I was able to narrow down my choices based on areas that, you know, I decided I didn't want to spend all my time on one thing versus something else. So definitely look at the academic calendars.
One thing I think is very important to remember is that we're making this seem very, very definite in terms of whatever stream you will pick is where you're going to spend all of your time, and that is statistically just not true. A lot of you will pick a stream here, go to school for it for 4 years specifically for that, and then never actually work in that field. But you will take those skills that you have gained to the fields that you go to, and that's one of the very important things. So that's one thing to remember is this is not the be-all, end-all. Part number two, what I actually did myself to determine what I wanted to do was I kind of narrowed it down to a range of acceptable fields, things that I thought I would enjoy, acceptable to me. Yeah, yeah. Yo, should I? Okay. No, but if there were anything that I couldn't see myself doing, obviously those are off of the top, but I had 3 or 4 different streams that I probably would have been happy in, and even at the end of 5 years of studying, I still think I would have been happy in any of those fields. The reason I'm happiest right now in mechanical is because I have found other avenues like clubs and different projects to supplement my learning that have fleshed out areas like coding and building circuits and all of those different areas. So don't feel like the decision that you make today is going to be that detrimental to you if you do decide to switch your focus later.
All right, so from what I heard so far, this is to Caitlin, by the way. Mechatronics is like very broad, and like my question is like, does that serve as more of an advantage, or can it stretch you out too thin, for example?
Yeah, I think it can serve both as an advantage and a disadvantage. It's really how you spin it. In some ways, yes, it's really cool to be able to learn like all this different stuff about the different fields. If you're really curious about like how things work, it's interesting to be able to like look in your life and be like, oh, like I know how this aspect of whatever works, or like this aspect of that, and like see how that all ties together in your education. And I think it also opens the door to like a lot of different co-op opportunities. For example, like I can apply to software internships, I can apply to more mech or hardware internships, and you have the background for both of those. That being said, like you like sometimes might have to do a little bit of work outside of the classroom to really hone in on some of the more like specific skills. So like let's say you're really interested in software, you'll probably have to do like more hackathons on the side, do a little bit more practice on the side, that like things that people in software like Simon might learn, but like you don't learn in your classes. That being said, like it's really possible, and I feel like regardless of what stream you choose, or at least I know like for software, like you'll still have to work outside of the class to get internships. So like my rationale for choosing Tron was like, if I choose software, I'll have to do it outside of class anyway, so I might as well choose Tron and then get that broad education and get to learn about things in mechanical, things in more elect focus, which I'm also interested in, and I feel like it'd be harder to learn on my own rather than like learn it through a class structure, if that makes sense.
My question is about mechanical engineering. I'm considering this field because I like CADing, for example, and on-hand things more than, let's say, coding applications or from a distance applications, let's say. So, but at the same time, I don't like physics 1D or 3 that much. So I don't know if I am thinking in the right way. Plus, I don't like a lot like the oil dirty jobs. Like, so is mechanical only for oil dirty jobs, let's say, or there are opportunities in, you know, other industries?
I will level with you. There is a substantial amount of physics in mechanical engineering. Now, that doesn't mean that you don't get to CAD, because you do get to do plenty of CAD. It's sprinkled throughout the entire degree. There's always parts of it to do, and there's always different projects to work on in and around the school that involve plenty of CAD. It's something that you can do a ton. Personally, I'm kind of in the same boat as you, where physics was not my passion when I entered mechanical engineering. It was more the design side of things, where designing something physical to solve a physical problem was what interested me. I don't think that you should necessarily let not a love of physics stop you from pursuing it, but if you genuinely hate everything that you learned in 1D03, it may not be the best decision. I will be honest.
I hated 1D03. I hated 1E03 as well. But I loved being in mechanical engineering for the past 4 years or 3 years. And like, yes, there are basic concepts like kinetics, kinematics, forces, things like that. But I just think once you go into it, the application of it is so much more easy to comprehend and understand, especially biomechanics. Loved that course. It is so important to what I want to do, which is like making prosthetics and designing medical devices. So definitely do not let your hatred potentially of 1DO3 steer you away from mechanical engineering, because I just like the way that the courses are taught is different, the application is different, and if you really love design and making things, then 1DO3 shouldn't be holding you back.
If there's a single thing that is manufactured that doesn't involve the manufacturing process, I have yet to see it. Everything that's around us has to be either built with something that is engineered by a mechanical engineer, or it is directly used by a mechanical engineer. It's involved in many things. You can be involved in anything to do with aerospace, anything to do with automotive, anything to do with biomechanics, anything to do with ergonomic design, anything that needs a CADed component, anything that needs to be built in the factory. Most factories, most processing for different raw materials, most acquisition of raw materials. I could really keep going on about this for a very long time. It's highly involved, and I don't want to put you to sleep. So I'm just going to leave it at that.
Kaylin, this question is for you again. Sorry to make you pass it all the way down to the other end again. I was just curious, like in terms of mechatronics, you mentioned like having to do some like projects on the side, which you would have to do in software as well, you said. But I was just curious in the actual course content itself, like where mechatronics was like less than software in terms of like what you learned in the courses themselves.
Yeah, I feel like in terms of like the core courses that you need to put on like your resume per se for software jobs, like data structures and algorithms and like intro to programming, you do hit those. I feel like once it gets to the more complex stuff, like I guess I could talk about it more. That's where we don't have as much. Like just one thing that stands out to me is I did software internships the past 2 summers, and my manager was telling me, oh, like you'll learn all of these courses, because my like other interns were in CS, and they're like, oh, you'll have these courses next year, and I was like, no, I don't actually. But like I think in terms of, I don't know exactly what I'm missing because I'm not taking them, but I feel like whatever I don't have, I was able to learn on the job.
Okay.
And it like worked out fine. I don't know if Sana, you want to say like the specific courses.
So I also don't really know about the specific courses per se, because I also never obviously was in Tron. But I was also facing this dilemma of whether I wanted to do Tron or if I wanted to do software when I was in my first year. What really helped me was the course calendar that they talked about as well.
Okay.
Personally, for me, like I really like the idea of Tron. But then I looked at the course calendar, and again about the physics topic again, was not the biggest fan. And I saw the EngPhys courses that you take in Tron, and I was like, okay, well maybe I'm just gonna stick to the software side of things, which I'm happy I did that. But yeah, like I know we definitely do take more, I guess, complex courses. And I don't know if you guys take like optimization and like things, yeah. So like we take like those stuff. That come up like in interviews and all that as well. So I guess there are more, well, obviously, right? You'd expect that, like, if you focus on one thing, you go in more depth.
Yeah.
But in general, depends on like where your interests really lie, I would say.
Okay, thank you.
Yeah, of course.
So question with regards to like, kind of for everyone, what if you already looked at the course calendar? What if you already weighted things out? What if you already crossed things out and then went to talk to a lot of students and uncrossed things out? How do you make that ultimate decision? Flip the coin? No. No, I won't flip the coin. I'm sorry.
I also know people that like put it in, had it in for weeks, and then the day of like completely changed to like the most opposite stream you could possibly pick the day of. And now they love it. So like just go with your gut. The other thing too is like you might not want to hear this, but I know a large number of people that have switched their streams after like second year and third year. So if you do end up in a stream and realize you might not be the biggest fan of it, you know, you can always switch. Like you can always like go into something and realize that this isn't for you and realize that there's something else out there, like other courses or another stream that you're more interested in, and work from there if you really need to. It's not be all in.
So, and we have had students who they choose one stream and then it's like, oh no, over the course of the summer or maybe into their second year or maybe into the winter semester of their second year or even after their second year, they decide this isn't for me. There are always possibilities to change, but what you want to switch to, like what you want to switch out of and what you might want to switch into, and when you decide you might want to do that, may impact the timeline in terms of your graduation time. So not by any means, not to dissuade you, right? We have had, you know, I think of a student right now who switched from one stream at this row to another stream at this row. They're in their fourth year and they made that switch because, and they're happy. Like it fits. It's going to take them an extra year, but they did what was best for them. But that's just something to keep in mind. That is possible, but it's not turnkey. It's something. Brennan is your best friend, your academic advisor. That's who you want to talk to if that's for you, and then he can help set that path.
So in case any of you missed the little exchange we had here, I did in fact pick mechanical because I flipped a coin between mechanical and mechatronics. And if you are down to that point where you have two, flipping a coin is an underrated thing to do because if you're disappointed immediately, you know which one you actually prefer. That's one thing. And also, I would encourage you all to trust your guts a little bit. It's not as though I'm sitting in a room of people that habitually make awful decisions. You're all iBiomeds. You're all very intelligent people, very capable. I would expect you to be able to make some kind of decision based on your heart and your head that is going to be good for your future. And I would you should all extend that courtesy to yourself. Give yourself a little bit of faith.
Okay. I think one other thing to mention is that like a lot of the streams, like in all of them, you do learn like basic engineering principles, and if like hopefully you'll have courses that you like. There will always be some courses that you don't like, but at the end of the day, all of them can lead you to where you want to go. You can apply to jobs that maybe don't have your specific stream in the job application, but you still can have the skills to do that job. So like don't be scared that you might not choose like the ideal stream. As everyone was saying, like you can switch streams. You can also apply those skills from your stream, and it could give you an advantage into having a unique insight into whatever jobs you are looking at. But there really is no wrong answer, and like either way, you'll have made like the quote unquote right choice that will help you in some way down the line.
This question is for Lauren. If you've had any co-ops in the past, would you be able to explain what they were, and what are some industry jobs that you can get after doing HESE?
That's a really good question. So for me personally, I haven't had any super related HESE co-ops in the past. In between my second and third year, I worked at Venture Academy, which is like a STEM summer camp that McMaster runs. So I spent the summer basically teaching 10-year-olds like how to breadboard, which was really fun. And then last summer, I worked in project management. So I was just testing the waters and different things. And for this upcoming year, I'm going to be working at Viavi Solutions doing R&D on optical instrumentation. So that's very HESE. But I would say one of the really great things about the HESE program at Mac is it's very much whatever you want to make it to be. After third year, all of your HESE courses are tech electives. And there are so many different stream options for you to pick. There's semiconductors, there's optics, there's nuclear, there's smart systems, they just added like a space systems. There's so many different options. There's computer engineering electives that you can take. There's quantum computing. Like it really is whatever you want to make it. So if you are in EngPhys and you realize that you have a passion for something specific, because you have so many options for electives, there's nothing really stopping you, or there's nothing really in your way. So like there's a large number of jobs that you can get. Like you could work in something that's a little bit more on the mechanical side. I know a lot of people do things in like semiconductors or things like that are more elect heavy. I know some people try and work in like space. I'm just trying to think of like companies that like I know someone right now that's working at Boston Scientific, some people do like research on like MRIs or things that are like machines in hospitals and stuff like that. So there very much is a wide range of co-op options. It's just you got to pick those electives that you're interested in to lead you to that spot, if that makes sense.
Okay. I had a question from Sena, and like it was in terms of software. I know it's a really like thriving major, but like due to that, a lot of people are going to that. And have you find that like in terms of like finding co-ops or even like after like graduating, a concerning thing that like a lot of people are going and it's being like kind of like overload or not?
Well, it is competitive, I would say. So it really depends on what you do outside of the classroom as well. So you can't just rely purely on everything that you're learning, because as you said, it is very competitive. But also it is obviously growing at a fast rate as well, right? So there's more job opportunities as well in the field. So there are more people, but there's also a lot of jobs. I don't think it's something that's going to be like obviously out of demand with AI and all the development that's happening in it. So I don't think that's like a point of worry per se, because there is a lot of opportunities at all times, and anything that you can possibly think of has a software component most likely in it. So yeah.
My question's for Poonam. I was just wondering what your sort of summer job experience has been like, or other co-ops. And then as a follow-up question, if you feel that, you know, being in HESE rather than more of a conventional health sci or life sci degree, that you have kind of an advantage or just kind of a different set of experiences and capability for jobs as well as grad school afterwards.
I love this question because the answer is yes. So the past couple of summers, I've actually been working in a chemical engineering lab. So even as a HESE, you know, in first year, you do learn skills like coding and CADing. So I liked CADing better than coding, so that's kind of what I stuck with. So in this chemical engineering lab, I do research with Dr. Zhang, which Frank knows very well. And I essentially am making like this placenta model, and that has a lot to do with 3D printing and designing things on CAD. So I would say those are the skills that I'm taking away from, again, those like engineering technical skills that I'm learning. In terms of how it's different from, let's say, a life science or health science degree, it really is those engineering concepts and skills that you learn and how you apply them. So I am working in a chemical engineering lab, but a lot of my HESE like friends are working in, let's say, an immunology lab or like more science related. So like anything and like any stream, you really do need to, I guess, refine the skills that you have and then use it to your advantage. So then I chose to take CADing and then refine those skills and use it to my advantage. In terms of graduate school and things like that, like Sofini like showed on the PowerPoint, I think HESEs really do a lot of different things. So they do work in consulting. So whether that be consulting with like the Ministry of Health and making new protocols for like the health system, or if you're consulting with, let's say, biomedical devices and things like that. I know some HESEs do work in like more the business space. So whether that be on like Bay Street in Toronto and you're like a tech, or you're like a business guy in like Toronto walking down the street with your really expensive coffee. Or I know a lot of, it's true. I also know a couple of HESEs who do enter that more industry engineering space. One of my TAs, I believe, worked at like R&D at Boston Scientific, and now he's working for another company that I don't really know the name of, but he has a very cool engineering title, even though he graduated from HESE. So once again, it really is about how you take those engineering skills that you learn throughout your 4 years in HESE and then exactly what you want to do with them. But I feel like that's with anything. You really do need to put in that out of class work in order to make that happen.
My question is also for Poonam. Are the courses in HESE like very like 1EP6, or are they more like content based and like where you write a midterm and stuff like that? Are they more similar to 1EP6, or are they like normal?
1EP6 is cell bio. Okay. Courses change all the time in this program. Yes. I would say it's a good mix of both because as HESEs, you do take more health science courses. Health science courses are inquiry-based, they are project-based. And I say project-based that are a little bit different than iBioMed projects. So iBioMed projects, you really do like prototyping and hands-on work versus the health science inquiry courses are more research and finding pathways and like signaling pathways and things like that. So I do think it's a mix. And then on top of all of those like iBioMed design courses and then health science inquiry courses, we also take business courses and like innovation courses. So I think you do get a good mix of hands-on work, inquiry work, and also just like you listen to a lecture and then you do midterms and things like that.
All right, so this is a question about EngPhys. So for Lauren, I really hope this doesn't seem like too much of a pointed question because I am actually super interested. It comes out of a place of curiosity. But like, so EngPhys, I've heard from, I guess the prof who was here and from you as well, that it's very good if you're indecisive in terms of exactly what stream you want to pick. And the part I don't get about is that it's also very much advertised that it has a lot of electives. It has the most customization. You can make it whatever you want. But like, if you don't know what you want, what do you do when you have to pick those electives?
I totally get what you're saying. It's very contradictory. For me, like when I say that I was indecisive because obviously I'm an EngPhys. Physics is in the name. I really love physics, and I was indecisive because I liked mechanics and I liked the electrical side, and I liked the idea of learning about quantum mechanics and applications of quantum mechanics in engineering. So I was indecisive in the sense where I wanted to learn everything and I didn't know how to narrow it down. But then the beauty of the applications of EngPhys and like all the applications that you sort of get is it takes everything and like it takes like the elec and the mech and the quantum and combines it into an application, and you just see how, because EngPhys is so broad, because there are so many different applications that combine all of those things together. So that's what we sort of mean. We're like, it's indecisive because it takes everything, like it takes all these physics concepts and smushes it into like an application, but that happens in so many places. That makes more sense.
So I've heard that actually materials has more chemistry courses rather than chemical engineering, but both of them seem to have quite a bit. As someone that really likes chemistry, which one has like more chemistry within the stream?
Are we gonna fight over this one or what?
I mean, we might. We really might. I think materials is more chemistry.
Oh, you guys, we have more customization, so we have more chemistry a little bit, but I think you guys do like in the core course, you guys definitely have more chemistry.
Yeah, I would say especially so it's the material science and engineering program technically. So there is those first, usually your second, third year are going to be very focused on kind of the science of it all, kind of how everything works. There's a lot of the how everything works, and you're looking at that chemistry behind it and why the material is the way that it is. A lot of materials is either discovering, or like when you're learning about it, you're discovering these new things, or doing R&D to actually create new things that are going to have a lot of chemical properties on the macro to the nano scale. So it's a lot of understanding the chemistry in order to actually find the correct applications. There's also some physics, but I would say chemistry is a lot different than what you're going to find in chemical engineering.
Yeah, I can speak on that. So actually, everyone in this row has taken the same amount of chemistry courses. We all just take Chem 1, AO3, 1 AA3, and one of the organic chemistries. So as a chemical engineer, I don't actually do any more than that. However, there is chemistry interwoven into everything that we do. So for example, in like second and third year, we do like your thermodynamics, your heat transfer, and your other sort of like core engineering courses. But there is an aspect of chemistry woven into that. So one of the courses in second year is 2DO4, and that's like Chemical Engineering Principles 1. And we do basic like mass and energy balances that I'm sure the mechanicals do as well. But there's a little bit of like a chemistry flavor to them. So we'll add like reactions to them. We'll add like different sort of like mole and mass mole balances as well. So that's kind of where we get our chemistry. It's integrated into our engineering principles, as I think materials is probably a little bit different.
Materials also has those thermodynamics, heat transfer, mass transfer. I would say it's chemical and materials engineering are very similar, especially in what you're learning. I would say it looks more at the mechanical applications, like what Aiden was saying earlier about how there's aerospace opportunities, automotive opportunities. Those are a lot of the opportunities in materials engineering with the information you've learned from courses very similar to chemical engineering.
Yeah, that's well put. So chem, we do have some similar opportunities, but you're right. It's more like the mechanical ones, whereas chem is more like the software and the like actual like chemical wise ones. So our biggest stream that we have in chemical engineering is PSE, process system engineering. Not biased, I am part of it though. That has like a lot of members in it, and it's more like software and computing based and like numerical methods based. So actually, even like in my co-op experience, I've actually never been inside of a lab. It's all been like computing, all like coding, all like software-based stuff. So that's that. So like, even if you just want to try a few different things, I think chemical engineering has a lot of like options for that. But if you want to focus on the mechanical stuff, I think the materials is the way to go for sure. Yeah.